Good evening or early afternoon, depending on where you are joining us from. Welcome to today's webinar, Beyond Observability, Continuous Improvement Workflows for Production in the AI Era. We're excited to get this webinar started, but before we do, we'll go over a few housekeeping items so you know how to participate in today's event. This webinar is a moderated discussion, which means that as an attendee, you won't be able to use your microphone or turn on your camera, but we do want to hear from you. You can use the Q&A feature in Zoom, which is found on your menu bar, to send messages to our panelists or to our hosts. If you're having any technical issues, let us know via the Q&A. For attending this webinar, you also had the option to register for a free gift. If you requested a gift and you have not yet received the link, also let us know via the Q&A. We will have a live Q&A session after today's discussion. Submit your questions by typing them into the Q&A window at any time. We'll collect those questions and address them at the end of today's presentation. You can also participate by answering polls throughout this presentation. So when we open polls, if you're on a Windows device, the poll window appears on the same screen as Zoom, and on Mac devices, that window will appear on the current active screen. Finally, if you miss any of the content or you'd like to replay it at a later time, you'll receive a link via email to view a recording of this webinar shortly after it becomes available. And that does it for housekeeping items. With that, we will get started. So welcome to today's webinar, Beyond Observability, Continuous Improvement Workflows for Production in the AI Era. I'm going to ask our panelists to go ahead and turn their cameras on so we can get started. And hello, I am your co-host, George Miranda, currently VP of Marketing at InsightFinder. My career background started as an engineer running large-scale distributed systems, mostly in the video game and finance industries. I'm also co-author of the O'Reilly book, Observability Engineering. So it's pretty fair to say that building reliability into production is a very close personal passion of mine. So I cannot wait to get into today's discussion. Also, my co-host today, Dr. Helen Gu, is even more passionate about reliability when it comes to AI. So Helen, why don't you go ahead and introduce yourself?
Hi, everyone. So my name is Helen Gu. I'm the founder and CEO for InsightFinder. So I started my career using AI for system reliability about like 25 years ago. So I published my first research paper using neural networks to predicting system problems in 2000, about 2001. And since then have been actually really passionate about building a reliable system that can actually help our engineers have better life. And so just on the personal note, my husband is an engineer, and I have been an engineer in various companies. I worked for IBM Research and Google in the past. So I'm experienced those tough production debugging session myself firsthand, and as well as also seeing my husband going through all those production outages. So my research has been focusing on how to develop really practical AI technologies that can actually be used for large scale enterprise production environments.
Cool. Thank you, Helen. All right. So first things first, I'm going to kick off our first poll. And our first poll is finding out what stage are you in with your AI apps or agents? We just want to get a feel for where the audience is so we know how to tailor today's discussion. The poll is open. We're going to leave that open for a couple of minutes so that you can vote. And while that's going, we're going to talk about going beyond observability. And so I'm going to kick off this conversation with a slightly uncomfortable truth for anybody that has spent years building observability programs, myself included. And so with that, right, I think the truth is that observability is necessary, but it is not the finish line, right? It is the foundation. And so in the classic SRE world, we learned this with deterministic systems. You can instrument everything. You can have beautiful dashboards and query systems and context-rich traces. You can have high cardinality everything, right? But still, outages happen when you least expect. And so, like, the goal of observability was never, to see more stuff. The goal is reliability, right? Predictable, safe, continuously improving systems that customers can actually trust. But now we need to take that same lesson and drop it into the AI era. And with AI, right, especially LLM powered systems, the shape of failure changes. Sometimes, it looks like latency, sometimes it's an integration error, but a lot of the time it's something that observability alone can't really neatly label. It's things like the answer is wrong, right? Agent took the wrong action, the output was unsafe, or maybe even like the answer was technically correct, but it was super unhelpful. So, what do we do, right? Yes, observability is the foundation. You still need telemetry, you still need traces, logs, and metrics, and you still need to connect what the user experienced to what actually happened in production, right? Because without that, you're still, you're just guessing and arguing. But, right, reliability requires more than just visibility, right? And it requires some additional muscles that a lot of organizations haven't built because honestly, we haven't needed them at this intensity before. And so, like the first of those is diagnosis, right? There's a difference between seeing a problem and understanding it. And in AI systems, it's really, really easy to treat symptoms and miss the cause, right? Like, what was the problem, right? Was it a retrieval failure, prompt regression, permissions failure, right? An API failure, model update? If the incident process stops at just like we saw an error spike and then, we restarted something and fixed it, you're just going to repeat the same incident again and again and again, just, wearing a different disguise. And so the other thing, right, is like having evals. And so, coming from the SRE world, we had SLOs and error budgets, right? But essentially, that was a way to define good and a way to detect regressions. And so with LLMs, evals are the equivalent, right? You need to be able to say, like, this is what quality looks like for the business and then measure it, right? Offline or in production. And not just did it respond, but was it correct? Was it grounded? Was it safe? And then finally, I think, you need continuous improvement. And this is the big one because the end game isn't, we fixed the incident. The end game is, we learned something and made the system harder to break next time. And so AI reliability has to be a loop from detection to improvement, right? And if you don't close the loop, you don't have reliability. You just have an on-call rotation with some extra steps. And so this is what we mean when we say going beyond observability, right? Like observability is necessary. It gives you the raw truth of what happened, but reliability is what you do with that truth, right? How do you turn that into better systems, better outcomes, and fewer surprises? So I'll pause there because I know Helen is much, much closer to the how of this and what this looks like in real workflows, right? Like where teams get stuck, how they operationalize things like evals and feedback loops without grinding delivery to a halt. So with that, right, Helen, how do you see teams bridging the gap from we can observe it to we can reliably improve the system?
Yeah, so I think there's a observability is only the first step, right? So I think a lot of companies in the past 15, 20 years has started to build this pretty comprehensive and robust monitoring systems collecting various data. So we are in the stage that we don't lack data, right? So we have plenty of data to actually figure out what's going on in our production environments. However, we still have various like serious production outages, right? So as you heard recently, there's outages cause flights canceled, right? So airline companies has to stop working for like several days. And so we see basically those news, AT&T stop working and you cannot get phone calls, you even cannot make 911 calls, right? So those serious issues still happen. So why? You might wondering why. So the company invested like billions of dollars into this space. Why we still have so many outages, right? Even with the most advanced companies like Meta or Google or Microsoft, they still suffering from outages. The reason is that the data actually has already go beyond the capability of human to really understand those data, right? So that's really the kind of initial kind of our mission is to actually be able to build an AI system that can actually automatically analyze the data and figure out what's going on, right? That's where the name InsightFinder come from. However, I think fast forward to today, so just extracting insights, right? For example, like George mentioned, so we can figure out what is the root causes, right? Not just the symptoms. And we can also perform predictions by identifying those early anomaly root causes that can actually lead to those major incidents. So we can actually send those advanced warnings to the DevOps engineers to prepare them so they can actually prevent the production outages. So so fast forward to today, right? So we have basically all kinds of AI technologies. And so we already seeing that the possibility to automatically leverage those insights, and then the AI agent will actually be able to automatically fix the problems, right, on behalf of the user. So they can actually handle certain on-call load. So our engineers can have a time to rest and then focus on most business critical tasks, right? So that's basically what we saw is a great opportunity, as well as it's a big gap in the current solution.
Yeah, no, I couldn't agree more. And so, I think this has interesting context with where the audience is. So, let's go ahead and see the results of that last poll. And I think, Helen, what I really like about this poll is it really mirrors what I see when I talk to customers, which is, folks on this call, we're in pilots or proofs of concept, right? Or in production, but for internal users, right? Like not really focused on customer outcomes and putting AI in front of customers. I think for exactly these things, right? Where we have an idea of like what monitoring is like, but being able to close that reliability loop still not quite where our audience is. And that when I talk to folks out in the field, generally mirrors what I see a lot of as well. So cool. With that, before we jump into the next topic, I want to go ahead and open also the next poll, which is we want to know if and where you are using AI agents, if at all, right? This is an interesting question, and I cannot wait to see the results. So let's talk about that in just a minute. So, when it comes to AI agents, this is what I will say, right? Quick scene setter for like why agents suddenly feel like they're the center of attention. So I popped by the AWS reInvent conference in Las Vegas 2 weeks ago. It's one of the perks of living here in Las Vegas, right? I can just pop by a 60,000 person conference like it's my neighborhood farmers market. And so, what I noticed though was the vibe this year was a little different. On the AI side, it was less, let's look at what this model can say, and it was more, let's look at what this thing can do. And so I wanted to introduce this article here. This is a Silicon Angle article that captured the shift with a pretty spicy thesis, right? So AWS CEO Matt Garman says we are entering a new era where agents are the new cloud, right? Bold words, big claim. And so, like, what exactly does that mean? If you look at the article first, AWS isn't framing agents as like glorified chatbots or co-pilots, right? When they say agents, they're talking about long-running autonomous digital workers, right? Agents that can operate for hours or days, learn team preferences, and collaborate in swarms. And Matt Garman's quote is basically that a lot of the value that enterprises will see from AI is going to come from agents, not just generative chat, right? So that was one thing. Second, around the expo floor, if you look at most vendors, it seems pretty much everybody has an agent of some sort, but the challenge continues to be the same, right? And I heard a lot of people asking when they were watching demos, like, how does this agent know about my business, right? In other words, how do we turn these things into domain specific specialists? And then third, and this is the part that like really made my SRE brain like perk up, which is there was a big focus on trying to tackle runtime layers, right? And so this is like all of the unsexy but mandatory scaffolding that you need so you can trust agents with real work. And that seems to be a common concern on everyone's mind from SREs to executives. And it's rare that I see that kind of alignment. But what I like from this article, there was a big framing statement. The statement was the cloud abstracted infrastructure, the agent era abstracts work, right? And so like that's the pitch. It's not a feature, it's not an incremental change, but it's a platform shift, right? So here's the questions I want to put out on the table. One, is this sentiment correct? Right? Are agents actually like the next organizing layer of cloud and enterprise software, right? Or is this just another hype cycle? Like the demos look great, but once it's production, like meh. And two, like Helen, what's your take on this, right? Like when you hear agents are the new cloud, what part of that rings true and what feels like, we're skipping some chapters like around reliability, safety, and operating this stuff at scale.
Yeah, I think as a distributed system researcher, I'm very close to basically the whole evolution of cloud computing because a lot of people at the beginning and they didn't realize the power of cloud computing is not really a new technique. It's the technology of distributed system, resource sharing, utility computing. This has been go around for 20, 30 years before actually AWS was actually created. So yet we see a huge adoption of cloud computing, right? So as a distributed system researcher, I'm really proud, like a lot of technology we invented for distributed systems, like, fault tolerance protocol, and so this replication, distributed database, all those things get really used by a lot of people. And the reason is that those technology are actually make it accessible and embedded into different business easily, right? So and AWS is now trying to build distributed system for you. AWS trying to provide this infrastructure for you so you can build your business on top of that. So that I think is the key, basically the business driver why AWS cloud computing is becoming so popular and so successful. And so to make an analogy, right? So the analogy to the AI agent, it's the same thing, right? So AI technology is now new. And so, those neural networks, right? So even like GenAI technology, it's not built on something that is new, right? So they are using neural network, reinforced learning, all those existing like techniques that has been around for like 40, 50 years. But what is new is that they actually apply to natural language that make a lot of people understand the AI insights much easier. And so it becomes so accessible to many people, right? So through the ChatGPT. So accessibility is a key driver here, right? So again, so in terms of the AI agent, right? So if you think about this, right? So you can treat ChatGPT as kind of the plainer version of your personal assistant, right? So you can ask ChatGPT for your questions. And so, however, going to the enterprise level, and so there's a big gap here, right? So like George you mentioned is that it is basically, different enterprise, different business has different requirements, has different contexts. So what you need is basically a platform that can make these agents really easy to build and really easy to tune and really easy to adopt, right? And so this is basically what we saw is the gap on the market. And I believe the analogy why they say agents is the new cloud is that so we need to take this platform approach to tackle this problem.
Yeah, and so it sounds like, we are indeed abstracting work with some of these agents. Which, looking at these poll results, I want to look at, the results of who's using agents and how. And so, this is actually pretty interesting because like while we don't see a lot of AI in production yet, we do see a lot of usage of agents in different settings, sort of all over the map for all the choices we gave, right? So it's interesting to know a lot of folks are using agents even without customer facing AI applications. So I think there is a lot to what's happening with agents here. So that makes me super, super curious about the next poll. And so for the next poll, we'll go ahead and open that one and share it. Uh, Note that for this poll, this applies to all of your AI products, right? Not just specific to agents. What we want to know is what are you tracking to determine if your AI is acting reliably, right? Because especially agents that are taking actions, that reliability matters. So I think this could definitely produce some spicy conversations. So I cannot wait to see your reactions to your audience. All right, with that, we're going to move on to talking about InsightFinder's new agent, ARI. And so, let me set the groundwork for this. I'll let Helen actually introduce Ari and talk to you about what our agent does. But I want to zoom out for a second and sort of talk about like why operational agents, so like SRE reliability focused agents actually matter. Right. And we see a lot of these showing up right now. So what I will say about Matt Garman's stance is that I think he's spot on that agents are a response to a very real operational mismatch, right? Because our systems have gotten more and more complex. We've been on this spectrum of increasing complexity, right? Even during like the course of my career. And that is increasing faster than our ability to operate those complex systems with only human attention. Right. And so here's what I mean, right? In the old world, and like by the old world, I mean, like 3 years ago, we were already stretched pretty thin, right? Microservices, distributed systems, Kubernetes, multi-cloud, third-party APIs, right? Like every new layer added more and more failure modes. And so we built like modern observability systems to see across that complexity. And like by and large, it worked, right? And then what did we do? We took AI and added it on top. Like we're just going to peg the accelerator on complexity. And so again, right, observability still matters. It's foundational. But that gap between seeing and fixing is just getting wider and wider and wider. And that's why I think that operational agents are actually pretty compelling, right? Not because we want a chat bot in our incident channel, but because reliability work is a workflow, right? And a lot of that workflow is repeatable, it's time consuming, and it really, really needs a lot of deep context, right? Because like think about what we do during an incident. One, we pull signals from multiple tools. Two, we correlate that to what change broke. Three, right, narrow down the suspects to figure out which one it was. And then we summarize those findings for other humans. We propose next actions, execute some safe remediations, and then we document it so that we learn from it, right? And like do a post-mortem. And then, ideally you codify that fix into your code and you ship it, right? Like that's a lot of steps, and I probably even missed a couple. But honestly, a lot of those are mechanical, right? They require access, they require context and pattern matching more than they require creativity, right? And so humans are, don't get me wrong, like humans are still essential for judgment, trade-offs, and risk. But I think we could better spend our attention on parts that aren't basically collect evidence, reduce it, connect it, and propose the path forward. And so I think that's why we see a lot of agents. And personally, I think that's why we built ARI, InsightFinder's new agent. So ARI is an acronym for Autonomous Reliability Insights. And with that, Helen, I will hand it to you because we can talk about that category all day, but I think what the audience really wants here is concrete, right? What does an operational agent actually do in a reliability workflow? Where does it plug in? What does it automate? How does it keep humans firmly in the loop? So can you walk us through how ARI fits into that picture and what it's built to do?
Yeah, I think you already gave a very good kind of groundwork for RA. Like you said, basically, the production system debugging is a very complex process. However, the general steps, right? So no matter where you actually debugging your system, you serve as RCRE, and what kind of system you are monitoring or how maintaining, the general steps are the same, right? So like you mentioned, those templates are actually look very similar. So that's really the opportunity, right? So first of all, Ari will actually leverage this kind of master template and following those steps for every incidents and that happen in your environments. So that's sort of the you can think about Ari as your kind of first line defense engineer, right? So we often say we have level one, level two, level three, and then you can think about Ari is your level zero support, right? So anything that happen, the first step can go to Ari, and they can actually start to collect information, perform correlation, and ranking the root causes, and provide the recommendations, and trigger the playbooks, and perform actions. And so these steps can all kind of automated nowadays using AI technology. And the other thing what Ari does is basically connecting with all your existing observability tools, right? So you might already have a lot of tools in your system. So whether it's basic log tools like Splunk, Elastic, or Loki, or basically metrics tools like Prometheus, New Relic, Datadog, and or basic tracing tools, AppDynamics, Dynatrace. And so all those tools produce constantly different data. And so they also generate lots of alerts. And so the problem with those existing observability tools is that they have too many alerts, right? And a lot of those alerts are false alarms, noises. And so if you feed those alerts directly to human, our really heroes, right? So who has to work really hard fighting the real production outages, and so you will literally burn them, right? So they were all kind of buried with all those like uh flooding of those false alarms. So it's very important to have some AI technology, right? So to kind of extracting real problems, that true problems, true anomalies out of those alerts. So that's basically the first step ARI does is to do constant continuous monitoring, right? So what actually differentiate from a generic chatbot like ChatGPT, right? So you can go to ChatGPT, ask some generic question, right? So how do I reboot DB2? How do I write the scripts to monitor applications, right? So you can ask all kind of generic questions to ChatGPT, and so they can give you the answer. But that's not really agent, right? So because it's not a continuous operation, right? So you want some AI agent that continuous monitoring system because you don't know when something will happen, right? So if you actually wait until outage happens, and again, your team are still reactive, right? So your customer already got impacted, your business already got stalled, and you already have a lot of penalty already happen, right? And so you want the AI agent to do like continuous 24/7 monitoring and proactively do things like investigation for you and tell you what you can do to prevent some potential problems, right? So that's basically what we want to help to achieve with ARI. And the last thing is that, like we mentioned, so even though the generic template is quite common across different companies, different organizations, the specifics of the business and the systems make those debugging process very, very domain specific, right? And so if you actually use ChatGPT, some generic foundational model, and it's 100%, I would say like it won't actually know your business, right? It won't know your specific data, and it won't be able to detect even anomalies because they don't monitor your system, they don't train their models with your data, so they have no way to know even what is a normal behavior look like in your environments, right? So those are fundamental things basically needs to be actually done by some AI technology that can work continuously, and can perform analysis in real time, and then can also adapt to different environments automatically, right? So this is basically what we invented as unsupervised machine learning or automated learning technology in my research group when I started my career as a professor at NC State, right? So those technologies has been proven in many production environments, right? So we work with Fortune 500 companies, including finance companies, telecom companies, technology companies. And so those companies actually seeing that after basically learning and training, and those models can really detect and predict the problems with really high accuracy. Because like I comment at the beginning, right? So nowadays we have tons of data, right? So we never lack any data, right? So we don't have a problem of have no data, right? So or basically need the data. We are in the kind of stage that we have a lot of data, and those data has a lot of information, and if you have the right technology, you can actually extract really important and useful information out of that. That's what ARI will do for you.
Yeah, and I love that, Helen. I think what you're saying is, across domains, what we've seen is, there is a pattern of that work that needs to be abstracted, right? And the challenge is how you do it specific to your application and your domain. And so I think this is a great setup initially for talking about ARI and sort of an agent and what it should do. And I'm really, really excited to get to the next part, which is how we differentiate and how we get it there, right? To really understand your specific business context. But before we do, I'm going to go ahead and go back to the polls that we've been doing because we asked, like, how is the audience tackling reliability, right? Like, what signals are you looking at? So if we share those results, you can see what I found really interesting here is it's actually like all over the map. Like I'm not sure quite what I expected here, but really I think what this is actually doubling down on is that we have more signals than ever to correlate, right? Whether it's user feedback or conversation logs and transcripts, traces, token cost, usage, right? Safety events. It's like we have more tools, more ways to detect what's happening than ever. And so I think it actually reemphasizes the point that what we need is a better way to start collecting all of that. I'm going to squeeze in one more poll here because we want to know how you are improving the output quality of AI today, because that's going to be our very next topic. And so if you know that there is a problem, how are you turning that into actions that lead to better quality, right? That's the point of our next poll. So we'll go ahead and open that, leave it open for a few minutes so you can vote. And I missed the slide here. We're going to talk a little bit about AI customization and learning, right? So we're going to shift the topic here to something that sounds deceptively simple, but this is basically the whole game if you care about reliability. Fine-tuning your AI for domain-specific purposes, right? Because in theory, everybody wants the same thing, right? Like we want that work extracted, but make the model understand my business, my product vocabulary, my edge cases, my customers, my policies. What is my definition of helpful, right? And yes, there are a bunch of ways to get there, as we saw from that last poll, right? Better prompts, better retrieval, better tool use, better guardrails, better evals, right? Classic fine tuning. Like the menu is long. There's a lot of stuff that we can try to use to get here. But if the goal is reliability, the fastest path isn't usually guessing in a lab, right? It's learning from production reality. And production reality is where the fantasy dies, right? This is where you learn what your products really can and can't do. And so I love telling this story. So a perfect example, McDonald's rolling back AI drive-through order takers. So if you're not familiar with this story, look it up on TikTok. There was automated AI order takers in McDonald's drive-throughs, right? It was a multi-million dollar project with IBM, world-class consultants backed by IBM Cloud. Like they did everything right. But within months, right, they rolled back. And again, if you don't know what I'm talking about, when you look at these videos, like the TikTok videos are hilariously bad because basically the system didn't work. And this is not a dunk on McDonald's, right? Or IBM, but this is the point of what I'm talking about, which is that AI breaks not because like the AI order taker can't speak English, right? Like it understands, but what happens is the real world is full of a bunch of different things like accents or background noise, weird phrasing, bad microphones and speakers in the drive-through, right? Local menus, people using slang, people changing their mind mid-sentence, right? Kids yelling in the back seat, like you name it. All sorts of things go wrong, right? And so you can do offline tuning all you want in a lab, but until you feed the system the shape of real production interactions, you don't really know what you're building, right? You're just building something that performs well in the reality that you imagined. And that's what I used to love about being an SRE and working in prod. Like that's where the rubber meets the road. Like, did your lab tested software, like, did it really do what you wanted when real people started using it? And so I think production data is such a superpower for domain tuning if you do it responsibly, right? Because that's the highest signal data set that you will ever get because it captures what users actually asked, right? What the system actually did, what good looks like, when it's helpful, and what failed in ways that you never expected, right? And then the reliability move is to turn that into a loop, right? Like you observe, you evaluate, you tune, you validate that model, and you deploy it, right? And then you observe again, and you sort of go into this continuous loop that isn't just like shipping a model and hoping. Instead, you ship a model and you learn on purpose, right? And I think that sets us up for the next part of the conversation, which is what does it look like to operationalize that loop, especially with agents in the mix, right? So, Helen, talk to us about how ARI learns your specific domain. Like, how do we get there?
Yeah, so I think first of all, we have to understand AI is statistical learning, right? And statistical learning means that it's based on probabilistic algorithms, right? And so even like, when you do ChatGPT and sometimes you find ChatGPT hallucinate or ChatGPT come up with some ridiculous answers, right? And the reason is that AI modeling is basically statistical in in design, right? So that's basically the theory behind it. And when you look at the statistical algorithms, the errors, the problems, the anomalies are inevitable, right? Because those basically are fundamental kind of built-in features of neural networks. And so, yeah, you look at the analogy, right? So it doesn't mean like when those LLM models or AI models make mistakes, you get scared, right? So sometimes, and so we need to look at what is your fault tolerance, right? So look at the sort of the analogy in distributed systems, right? So if you look at the early research results of distributed system, we all know distributed system is not 100% reliable, right? And so if you look at the SRA, right, so everybody's saying, oh, I provide a 9.9995969 reliability, but nobody ever say I have 100% reliability. Why? Because there's always a theory behind it. It's impossible to achieve 100% reliable distributed system, but yet we still use it, right? So it doesn't mean like a distributed system is not useful, right? So again, it really creates the internet, create the cloud computing, right? So the trick is not really be afraid of the problems, right? So reliability is not something saying like you can build a system that is 100% reliable, then you use it. The trick is that you have to understand is that you need to think the system will make a mistake, right? That should be your starting point. That should be your assumption. So now the question is that how do you actually take can detect those problems, right? And this problem detection can now be basically like very delayed, right? So it can be like after several weeks or months, then you have data scientists to analyze it and you realize, oh, something wrong. So you got to actually detect the problems quickly, and you also need to have a way to actually quickly correct the problems, right? So when the problems happens, and if the AI agent can actually understand, okay, I need to get updated, right? And so this is the problem I will correct. So then that will make AI super intelligent, right? So just like human, right? We all make mistakes, right? So no matter how expert, how many years of experience you have, and you will still make mistakes, but that's okay, right? As long as we know and there's someone tell you this is wrong and this is the correct way, and you learn from it and you become improved, right? So this is basically how ARI kind of operates, right? So first of all, we use our composite AI technology, right? So one thing that I kind of mentioned that briefly at the beginning is that so like GenAI technology is invented for analyzing natural language and perform basically the text generation using token prediction, right? That's essentially what's the technology about. However, it doesn't really work for like numerical metric data, right? So you cannot use ChatGPT to predicting time series, right? You cannot use ChatGPT to perform anomaly detection for metrics or for logs, right? So they are now built to do that. And so you need a different AI technology to actually analyze different data, right? Especially in the observability, like IT operation space, you are dealing with very, diversified data, right? So you not only have like, natural language, right? So that's only a small part, right? So we do actually need to look at like some tickets information, Jira documents, but the majority of the data are basic numerical data, right? Like a metrics time series or basically log data, right? So it could be structured, semi-structured. So you need to have different technology to learn from that. And the other thing, so what I mentioned is that you need to find the AI technology that can quickly learn and adapt, and more importantly, to learn by itself, right? So it's kind of self-learning. So that's basically the kind of the design principle. We start with design ARI is that first of all, ARI is built on top of composite AI technology. It can actually leverage different AI models to actually process different kinds of data. And then the second is that ARI is actually perform online evaluation and learning by itself. And so because it's not just actually provided, solutions, but also constantly evaluating itself. So we have separate real-time evaluation system to actually cross-validate each answer, solution, or action coming from the AI agent ARI. And then we can actually dynamically create the training data set out of those evaluation results. And so then we can quickly update the model. And so the model can actually fine tune pretty much like, with the data immediately, within hours, right? Even training like, ChatGPT, GPT-4.1, we can actually finish the fine tuning within 30 minutes, right? So this is basically allow your model quickly updated based on the production data, right? Because you never know how your model performs until you really use it in production, right? Just like any our applications, database we use in the past, and so that's the best test is your real production usage, right? So
Yeah, I want to be mindful of time and leave room for like plenty of demo because I think it helps to see this concretely. And so I think that's a wonderful setup, Helen. And I want to share the last poll here and share the results, right? Because when it comes to improving AI quality, by far and away in our audience, it's human review and like spot checking QA workflows. Like, is your AI doing the right thing? And we see a little bit of usage of some of the other methods like prompt iteration, right? But wow, like this says a lot about the state of what we are doing to ensure that AI is reliable. So this really makes me want to jump into the demo, which is, right, Helen, this is what we are all here for. Can you show us a concrete demo of how it all comes together and how we go from seeing an error to fine tuning and making ARI customized to our domain?
mhm. Yeah, absolutely.
All right, let me go ahead and
Let me
stop
share
sharing.
my screen. Can you guys see my screen?
Yes.
Okay. All right, so I'm going to show two parts, right? One is the RA itself, and the other one is how do we actually evaluate RA, and monitor RA, and then fine tune RA, right? And so RA is basically a kind of agent running 24/7, right? And so when you log into your system, and so the first thing you will see is ARI will provide an immediate summary on what's happening in the current day, right? So right now I'm entering basically a citizen Kane system, which is a three-tier web services, very common e-commerce system. And when I entering this system, and ARI basically greeted me and tell me there's actually one incident happened, 11 metric anomalies detected, 9 log anomalies, and 4 change events. So more importantly, it's actually tell me what kind of action is actually have done in the past, current out, like the current day, right? So in the past 12, 30 hours. And so it basically tell me, okay, first of all, at 120, it actually detected as a low availability incident on the web portal. And then we basically also find out, interestingly, ARI also make a prediction before that actually a low availability happened. And so it actually predict that will happen. So that's basically showing that ARI is performing analysis on that and anticipate that there's going to be a low availability issue. And then basically it shows that there's some action taken, right? So in this case, the action taken was a little bit delayed, right? So it's action actually triggered a little bit later. And so because we were just testing, right? So And then it shows that what action actually taken, and then this incident basically didn't recur later today, right? So this is a very common case, and the reason why ARI can show this, and it's because it's perform all the analysis behind the scene, right? So now given this, and you can dive in and you can ask some specific questions. The other thing you can do is also like there's different models you can use. And so now I just switched to GPT-4.1. When I switch the models, you can see the screen refreshed because it's actually switched to a different model. The context got reloaded. So I want to use this. This is a default GPT-4.1 model, right? And so you can actually use ARI for different models. And so you can start to ask, okay, what is the root cause? So you can ask the root cause like details for specific incident. So then it will go ahead to actually search the results and retrieve the information, and then basically organize it. So this is basically tell you, okay, this is a low availability incident happened on 1:20 in the morning, and so this is the root cause chain, and so we detect a change event. There's a deployment happened to the checkout service at 0:31, and then basically about 20 minutes later, you will start to see the core server actually start to experience a set of anomalies, and then you start to see, okay, at 1:05, you start to see this application error logs fire uploading failed, and then you start to see this 500 error start to happen on your web portal. That's eventually lead to basically your low availability. So that's basically, ARI actually analyze all those data. So as you can see, this includes change events, metric problems, and then log problems, and then the error codes, the traces, etc. And also ARI can give recommendations what to do, right? So based on that, you can also navigate to some details, right? So what's going on with this? So I will give you a summary, but you can also view the details. So we also have the traditional dashboard, and you can see, okay, what are the incidents detected, and what are the root causes actually being identified. And this will show you the root cause chain, and will show you basically what's happening when this incident happened. And will also give you the detailed root cause summary and as well as recommendation. So ARI can also make predictions, like I mentioned. So not just detecting problem, also predicting things ahead of time, and it perform basically self-validation, right? So we'll see whether this incident predicted and indeed happened. Like I mentioned, in the morning, 1 o'clock, ARI made the prediction this availability will actually drop below your SLA, and then it actually indeed happened. And so it can also create tickets, ServiceNow tickets for you automatically. It can create Jira tickets for you automatically, send a notification to you through email, Slack, phone call, etc. So this is basically what you can use ARI for, right? And so let's come back, right? So let's say you want to ask like ARI about some specific questions related to specific domain, right? So now I'm switching to GPT-4.1 now. So now I basically, let's say I have a Windows error I need to debug. So I will ask this question, right? So what is Windows error code 0x14f? So this is live results, right? So this is GPT-4.1 today. And so let's see what GPT-4.1 will tell me. So again, this is a generic model, right? So this is a foundational model trained by OpenAI. And so using whatever secret training data and, training process, and no one knows, right? This is a black box. Okay, now I got answer, and I got a really long answer. And so ChatGPT tell me, oh, this is an error invalid address, and there's a bunch of things, and they even give me troubleshooting steps. And if you're not expert in this space, and you will easily believe ChatGPT is telling you the right answer. And ironically, this answer is totally wrong. And so, and you can ask Anthropic, you can ask Gemini the same question. They will give you different answers, and all those answers are wrong, right? And so you might wondering, right? So how come like a simple error code question, and imagine this is an error code that's specific to a business, and how come this foundational model cannot do this, right? So that's basically like I mentioned at the beginning. So those foundational models trained based on the human language, right? The common language. And those questions are not commonly asked on the internet. So OpenAI is now trained by the knowledge, right? So the question is that how do you catch that, right? So if you don't have a mechanism in place when those error happens, and you don't know even that happened. So that's why we have our AI observability product to constantly monitoring those agents, right? So this is the trace we collected for ARI. And so this including real-time monitoring what happened to on ARI, right? So we will actually automatically identify what are the failures happen, right? So we identify two kinds of failures. One is evaluation, right? So we'll identify whether there's a hallucination, there's basic factual inaccuracy, and the other anomalies we identify are performance anomalies, right? So this is basically take a longer time to process. And you can also see like, what are the prompt and the response associated with each failed transaction. And you can also click into details, see what's happening, why we think this is basically anomalous. And so this will give you explanations. And so, the 0x14f is actually a PDC watchdog timeout. And that's basically, but the answer tell me it's an invalid address, right? So that's the reason why basically InsightFinder think this is wrong. And the reason why we can do this is that we have also fine-tuned the Judge LM and for different domains, right? So we have particular for IT operation domain, we have been working in this space for 10 years now. So we accumulate a lot of like knowledge and experience in this space. So we fine-tune our Judge LM to catch those problems, right? So that's the reason why we can catch that. But the trick is not just catch them, right? So like catching them is the first good step. The second step is that how do you fix it, right? So how do I make the model is actually fit my business environments, right? So that's basically the key goal we want to achieve here. So that's why we actually provide this automatic fine-tuning dataset generation capability. So based on this evaluation results, and we can automatically generate those fine-tuning data set for you, right? Whether you use the Gemini or OpenAI models, and you can pick the providers, and then the system will actually automatically create those data set based on those evaluation results. Essentially, because in the evaluation we have the explanations, we can use the correct answer to replace those wrong answers. So this is a data set I generated before this demo session. And as you can see, this error code is correctly associated with the right answer now. So with this right data set, also this includes basically a chance for human to actually edit that. So you can have your experts and domain expertise still review this data set, right? The good news is that you don't actually need to review like, millions of transactions and prompts, conversations happen in your chatbot. And this is basically those things are actually already detected, right? Flagged as wrong. And then you can actually just focus on those, laser focus on those problematic ones. Now, once you have the data set, the next step is that you can fine-tune your data set, fine-tune your model, right? So you can pick any model, foundational models, right? And then you can fine-tune it. And you can pick the name. And then once you start fine-tuning, we will automatically create these jobs. And then you will see those fine-tuned models. And then you can start to use it, right? So for the sake of time, I do have a model already fine-tuned actually right before this demo. So I fine-tuned this based on the Windows error code we just have the detected. So now let's ask this question, right? So this is actually a fine-tuned model based on GPT-4.1. So you can ask the same question, and now basically, let's see whether ARI can answer that correctly. So now ARI will say, okay, this is a PDC watchdog timeout, and that's basically the correct answer. So now you can see this fine-tuning process become really, really easy. And so just with a few click of buttons, you can easily tune any foundational models like Anthropic, GPT, or Gemini to fit your business and provide highly reliable answers to your customers.
I love that demo because that is exactly what we were talking about, right? It's not just rolling a model that was built in a lab and hoping for the best. It is trying it in your actual environment, right? Knowing that, it's pretty well tuned out of the box, but if we find something that isn't specific to our domain, here's an easy mechanism to detect it, right? Based on what our users are asking it to do, right? So in this case, presumably your internal SRE and like DevOps developer team, right? Interacting with this agent, and if something is wrong, right, here's an easy way to detect that, see it, create the data set, fine tune the model, right, and make that agent iteratively better. So closing the loop, right? You weren't just able to detect that, you had the observability to see it and all of the steps required to roll a change and deploy it. We're really short on time here, and we have a couple of questions. We have a live Q&A scheduled, and so here's the first thing I will say. If we don't get to your question, and again, if you have a question, please feel free to submit it. I think we're going to have time for one maybe. So we'll follow up with a blog post answering all of the questions. I'm going to pick my favorite here out of all of the questions because I think it relates to something that we were just talking about and we haven't addressed, which is how do you make sure that updates to the AI models don't regress quality? What checks happen before changes go live, right? Oh yeah, so let's say, Helen, right, we gave the training data something that was inaccurate. How can we check for that before deploying it? Like what
Yeah,
mechanisms are there?
so I actually forgot to show this. Can I just quickly show this?
Sure.
So we do have basically a LM labs, and so this basically allow you to actually quickly test the model you fine tune. And so once you fine tune these models, this model will be immediately available in your LM labs page, and you can create the sessions, and then you can actually use the evaluation data set. Will also automatically generate this prompt library for you. So those prompt library, including the prompts that failed, and then you can actually immediately test this model. And you can also do A/B testing across different models and see like whether this fine-tuned models breaks any existing prompts and to create more problems. So and you can do a comprehensive evaluation across different models with these fine-tuned models in terms of accuracy, safety, bias, as well as cost and performance. Yeah, just want to quickly
Excellent.
show this.
All right. With that, that brings us to the end of today's webinar. I want to thank Helen for that great presentation. Thank you, audience, for participating in the polls and the questions. There are about 5 other questions here. So we will follow up with answers to those questions. And again, you will get a link to this recording if you want to rewatch any of the content as soon as the recording becomes available. So thank you so much. Also, somebody just asked for my email address. I am george@insightfinder.com. That's pretty straightforward. So if you have questions you want to reach out, please do. And again, we'll follow up with a link to this recording. Thank you so much for your time. Thank you, Helen, and have a wonderful day.
Thank you. Happy holidays, everyone. Bye.